One of the assumptions of pricing model is that prices make a random walk. The past movements in prices don't predict the future price movements. This makes the movements in variance proportion to movements in time. For example, to calculate annual variance, you multiply the total variance with 1 over the total number of years. And as you know, the standard deviation is the square root of the variance. To find the annual standard deviation, you multiply the total standard deviation with the square root of 1 over the total number of years, like in the short formula. So mathematically, the standard deviation increases less the longer the horizon. To illustrate this, we will use the risk and return of the S&P 500. The S&P 500 has about 9% yearly arithmetic return and 15% yearly standard deviation. We will calculate what the return will be in 10 years and what the standard deviation will be in 10 years. We will use this area here. This column will be the year. To calculate the return for each year, you just take 1 plus the yearly return, put the bracket here, rise by the year minus 1, and just drag down the formula. So in year 1 you get the return of 9%. You reinvest the return, that gives you 19% total return in year 2, and so forth. Remember, this is just a mathematically average return calculation. You might get a higher return than 9% on one year and lower than 9% on the other. The numbers don't account for inflation. We insert the data into a graph. So insert, scatter, right click, select data, add, the X value can be the year, the Y values will be the return. There. As you can see, the return keep rising the longer you hold the investment. Now let's calculate the variance and the standard deviation. So there. So you just take the variance of the S&P 500 multiplied by the number of years. And standard deviation is the square root of variance. So we just put the data into a graph, insert, scatter, select data, add, X value is the year, Y values the standard deviation. Okay. As you can see, the standard deviation doesn't rise as sharp as the return the longer you hold the investment. Let's plot both data into one chart. So insert, scatter, and select data, add, X value is the year, Y value is the return, and then select data, add, year, standard deviation, see that the longer you hold the investment, you will have more to lose, but the volatility rises slower. To sum up, stock pricing model assumes a random walk in pricing. The past movements don't predict the future movements, thus making the movements in variance proportion to the movements in time. 2 years variance is equal to 1 year variance multiplied by 2. And standard deviation is the square root of variance. So 2 year standard deviation is equal to 1 year standard deviation multiplied by the square root of 2, thus making the standard deviation move slower the time horizon. As mentioned in one of the previous videos, standard deviation is what most analysts use for measuring risk.